Let's do a recap of what we've been talking about in sections 7.1 and 7.2. So law of sines and law of cosines. So remember, we first started talking about law of sines. So what was the combination of sides and angles that you have when thinking about using law of sines? Those combinations would be if we have a side and two angles with that side not included, if we have a side and two angles with it being included, so it's angle, side, angle, or if we have two sides and the angle not included. Remember, that situation creates the ambiguous case where you could have either no triangle, one triangle, or even two triangles. Then we talked about when is it that we want to use the law of cosines. Remember, law of cosines is when we have two sides and an angle that is included, or if we have three sides. Okay, so those were the combinations of the different sides and angles and which one of those two we want to use. We also talked about how to find area of a triangle. When we had two sides and an angle that was given, we took half the product of the two sides times the sine of that angle. So remember, that was the situation though when it was side angle side. The angle was included in the two sides. However, that's not always going to be the situation for finding area. Sometimes you might not have that combination. What if we only have three sides given? Well, there is another formula that we could use in order to fit this scenario. And that would be something called Heron's formula for the area of a triangle. So when you are given three sides, call them A, B, and C, to find the area, we would take the square root of s times s minus a times s minus b times s minus c. So what is S standing for? S is 1/2 its perimeter. So remember, perimeter is adding up the sides. So because we're talking about a triangle, there's three sides. So add up the three sides, take half of it. That gets us that variable of S. So that's what we would have to do first. And then we could plug it into the formula and we'd have area. So let's do a quick example of that scenario. If I want us to find the area, notice that I am giving us three different sides. I'm giving us A to be 6 meters, B to be 16 meters, and C to be 18 meters. And we want to find area and round to the nearest square meter. Okay, so remember when you're given the three sides, you want to find S first. So we want to take half the perimeter. So I want to add 6, 16, 18 together, and then take half of it. So if we do that, 6 plus 16 plus 18, that gives us 40. So if I'm taking half of 40, we just found that variable of S to be 20. So then to find our area, we once again, under the square root, we want to do 20 times. Then in parentheses, I want to take that 20 and I want to subtract one of the sides, so 6. I want to multiply that by 20 minus another side, so 16. And then I want to multiply that by 20 minus the third side of 18. Once again, it's all under the radical. So you can then just very carefully put all of that in the calculator. So under the square root, we want 20 times 20 minus 6 times 20 minus 16 times 20 minus 18. When you put that into the calculator, your calculator will get you 33.456 and so on and so forth. Looking at the directions, though, it says round to the nearest square meter. So that means we're looking at this first decimal to tell us if we want to round up or not. Since it's a 4, we do not. Oops, so that's going to stay 33. And then once again, this is in meters, so it'd be meters squared. There is the area of this triangle.